Hello there, and today we want to be talking about the trigonomic functions, but the graphs of them. As they are functions, we can graph them. Now, the first one I've got here on my CAS calculator is the sine graph. Now, what you might notice here is that it is cyclical. Goes in cycles, I'll say that. So it repeats every 360 degrees. So just focusing on our 0 to 360, we start at 0 and go up to where x 90 degrees, and of course at 90 degrees, sine 90 degrees is 1. Down, 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 that's 180 degrees, sine of 180 degrees is 0, and then we get negatives. Now, you can relate this back to our unit circle. Think about the values of sine, the angles, when, between 0 and 180, it's in those two positives quadrants for sine. And then we get into the two negative quadrants for sine. We've got where our x is 90 degrees, our y value is 1. And that, of course, correlates to our unit circle. And this works even going backwards into the negatives. So we've got negative 360 degrees at the end there, so that's negative 45, negative 90, negative 180, negative 45, negative 90, negative 135, negative 180, etc., etc. Okay, so that's our sine graph. Now, I've shown it here from negative 360 degrees up to 360 degrees. And we've got two repeats here. So you can see it goes up and then, oops, let's get that back. Didn't want to do that. So you can see the power of the CAS. Yep. Just a sec. There, fix that up again. So you can see that there's two cycles. It starts at 0 degrees, our y is 0, and then it goes through the full cycle, then it's back to 0 again at 360. Now I'll zoom right out a bit more. Windows zoom, I'll just use the zoom out, center it here, and you can see how it cycles, all the way through. Now, I just took a snapshot in my settings here, and I'll go back to what I had, so negative 360. I'll show you how to do all of this later in the video. And leave that there. Negative 3, positive 3. There we go. Okay, so we can see we've got that two cycles, or periods as we call them. So one period in our sine graph, you can see, is 360 degrees. It's 360 degrees there. Now we have something else that we'll talk about. It's the amplitude. That's like the height. It's the height. Now here in our sine graph, we compare it to the mean value. Now the mean value of our sine graph is 0. So almost like the middle. So it 0 goes up to 1, 0, down to negative 1. So our amplitude is 1. That's its height almost. So here the period is 360 degrees and the amplitude is 1. Now here I've got my cosine graph. My cosine graph. Looks very similar, doesn't it? Very similar. But where the sine graph started at 0, went up to 1, then back through 0, down to -1, and back up to 0 again. If we're looking from the 0 to 360, we start at 1, move down through 0 to -1, up to 0, then back up to +1 to start the cycle again. So that cycle is still 360 degrees, and that amplitude you can see is also 1. Our sine and our cosine graphs are actually very closely related. The cosine is actually the complement of each other. This is why one of the reasons why I'm pretty insistent that you say sine, not sin, because it is sine and this is cosine. Back to the cosine. So you can see at the cycle, the period is 360 degrees. You can think again about back to that unit circle. The unit circle is 360 degrees around, and that first quadrant, if we're starting from 0 degrees, our values of cos of any angles is positive. They get smaller and smaller until you get to 90 degrees, when cos of 90 degrees is 0. And then they're negative for 2 quadrants, aren't they? The values of cos. Remember, all students take cake. So these 2 quadrants, the value of cosine's negative. They go up. So it goes down to -1, back up to 0, and then that last quadrant up to +1. So there's the 2 of them compared to each other. So they are the same shape, the same repetitive shape. Now I haven't put any boundaries on sketching these, that's why they'll just go on and on forever. But they're actually, it's like they're phased, a bit differently. They're sort of 90 degrees difference from each other. Just that sort of transition. No, not transition, but you can think about that 90 degrees difference in value. And that's what the 2 of them look compared. Now, our next one is our tangent graph. Now this looks a lot different, and there's a bit going on here. In some of the other videos I got you to watch, you would have seen that because tan is sine divided by cos, that's why we get this different shape. Now, so let's talk about what's going on here. These dashed lines are what we call asymptotes. Asymptotes. So the line of the function of tan, and all of these lines are the function of, they don't connect up to each other, but what's happened is that they approach the asymptote and get closer and closer and closer to that asymptote, but are never actually equal to that value. So let's say this one is at 90 degrees. What's tan 90 degrees? It's undefined. That's because this line, our graph of the function of tan, never meets that value. Okay? It's an asymptote. Now you can see that there's no amplitude or height like we had in cosine and sine, because these lines are infinite. They keep going up and up and up. But there is a cycle, a period, isn't there? Now what's that cycle? We've got 90 degrees there, and then another 90 degrees there. So that cycle is 180 degrees. and it's bounded by 2 asymptotes. So on either side, it would never quite meet that value of positive 90 degrees or negative 90 degrees. You can see along that it will keep on going. Now let's go back to my sine while I'm here. Now a nice little thing when you are using your CAS calculator is this is a graph page. I'll introduce them to you in a moment. Control T brings up a table of values. So you can see my x values here, and that's my function, sine of x. So if I go up, let's go to what we know there. Sine of 30 degrees is half, as we know. And you can find all of those values. So that's a nice little thing to see. So Control T, get rid of that. Okay, now let's make new graphs. All right, I'm going to pause it here and then come back with a new document. Okay, so in our new document, I'm going to make a new page, which is add graphs. Now on our home page, I could have also picked pages that way and pick graphs. I'm going to say it again, do not pick scratch pad. It doesn't have full functionality that you do with documents. Don't use it, don't get into that habit, okay? I really want to ask the TI people why they even have it there. Yeah. Anyway, so one thing you might see is this radians up in the corner. Even if you've got the whole whole document set to degrees, your graphs may be set to radians. Now, this is going to be very handy when you're in Year 11 doing methods, because you're going to use radians for doing these graphs far more than degrees. But here in Year 10, we're going to be using degrees. So you're going to want to change that for the graphs page. So that'll be the first thing we do. So go to Menu and then Settings, and this graphing angle, you want to change that to degree. Okay, I could make it default, but I'll just leave that. Okay. All right, so how do I make a sine graph? Well, easy enough. I go to my Trig, sine x, enter. There we go. Oh no, that doesn't look very good, does it? Now this is where you start fiddling a bit, and you'll get quicker and quicker at it. So I go to Menu, Window Zoom. Now you could just zoom out till you get something you like, but I'll zoom fit. How does that look? No, it still doesn't look very good. Window, Trig. Yep, that looks pretty good. Except, that might be a bit big. I don't really like all the things that are there. I had it set up so it was every 45 degrees, which, makes sense. So, Menu, Window Zoom, Window Setting. So here I can set some boundaries for where I want my minimum and maximum to be. An X scale. So here I might decide, well, I want that 45 degrees. That sort of makes sense. That's not too bad. I can decide, half, or let's make it 1. And there we go. There's a better looking graph, isn't it? I could have that a bit less. Let's leave that for now. I'm not going to fiddle with that label too much now. Okay, so let's make another graph. So to get our functions up, tab, If I arrow up, I see, oh, there's my original function. All right, let's look at this amplitude. So I'm going to go 2 times sine x. Now, before I hit enter, what do you predict it's going to look like? Get that picture in your head? Enter. Now, if you said it's the same shape, but it goes a bit higher, you'd be correct. So you can see here, well, it's just 2 times the values of the original sine graph, which is blue. But it's the same shape and also the same period. Okay, so it has to cover that same cycle over the 360 degrees as well. All right, now I'll hit tab again to bring up my equations. I'll untick the amplitude one and then I'll make another one. This time, let's change the period. So 2 times x, enter. Okay, so here you can see the original one, that cycle is the 360 degrees. It takes 360 degrees to go through a full cycle. Now, what's happened? Over the 360 degrees, this new one, the sine by 2x, it actually covers it twice, doesn't it? It covers that cycle twice. So our cycle is now half. It's now 180 degrees. Okay. Same thing happens to our cosine. Okay, maybe get out your CAS and have a fiddle with that. I always like students getting out their CAS and having a look at these on their CAS. It's a nice accurate way of looking at it. Now let's have a look at our tan function. Okay, I'm going to make a new page, so Control I, and again I'm making it a graph page. So put our original in, tan x, menu, no zoom, trig, yep. Okay, now I'll fiddle around with that again. Windows zoom, Windows settings, have that X scale 45. I think that makes it nice and clear. Okay, now it doesn't automatically come up with those asymptotes. Okay, it doesn't automatically come up with those asymptotes. I put them in as x equal 2 lines. So let's see what we can do. So here you can see that period is 180 degrees. 180 degrees. One way you can really clearly see that is between the values of 0. So let's tab and let's have a look what happens when I go to x, when I change that period. You can see that that period is now 90 degrees. Okay, x halved. X now halved. So instead of one cycle happening every 180 degrees like it was with the original, one cycle happens every 90 degrees. Now get that off, that's very confusing. So tab, arrow up, and untick it. There we go. Now, if I might just leave that one there, and you can have a bit more of a fiddle with your CAS calculator and see how you go with sketching these. Now you can do it on your CAS calculator, then sketch it by hand. That's a really good way to make sure you are getting things accurately. One thing we are going to be strict on is, you see how these are nice smooth curves? You are going to have to try to do your best to have those nice smooth curves. They are not straight lines, they are curves. Okay, so in the exercise, that's what you're going to try to replicate. Right, let's actually look at a few other things we can do to these graphs. I'll tab. I might actually just start a new problem. Doc, insert problem, graph. Okay, so got my sine x. I always like starting with the basic one, and then going through and making my alterations. So it always gets compared to our basic shape. All our graphs have a basic shape and position, and then we are translating it or doing other things to alter it. So yeah, I'll make that 45 and that's 1. Okay, so let's see what happens if I make that a negative sign. What do you think will happen? So it's -1 times y sine of x. It's a reflection. It's a reflection in this x-axis, because it's that -1 times by the sine function. So it becomes that reflection in the x-axis. Now I'll do another one. So Control I. Now another cool thing you can do on your CAS, I might do cos x. So as I was saying, this goes on for infinite. It goes on forever. Okay? It goes on forever and ever and ever. But what we could do is restrict it. Restrict its domain. So, don't need that. So, if I go up here, tab, go to my function. Okay, at that function, and then I Control Enter. I use this little symbol I call given, and I want it to restrict it to between, the x is between 0 and 360. Okay, that makes sense. Okay, so 0. So x Control equals, so you can see we're forcing it that x is only between 0 and 360. Enter. Okay, I can move that and see it all, and now I can also, in my window setting, that looks a bit ugly, -90, make that positive 450, again 45, -2, +2, let's have that as a half really. So here I've just got the one cycle. Okay, the one cycle. happening, and it's really clear. And sometimes you'll see that you're asked just to look at one cycle of our function. And let's so tab, if I let's just copy that. Copy. And I'll go 2 times. So you can see what it looks like over that 360, that pink. Let's actually tab. Control copy. Tab, copy. And see what it looks like here. Yep. So you can see a few things going on there, and it's just restricted over that domain of 360 degrees. So there's a lot of things happening here. I strongly recommend that you are using your CAS calculators here that was on the book list to have a look at a lot of your different functions, and we might make up a video or show you some more of these in another time.